So the next one in line is Valentin Völkl. He's going to talk about the streaming optimized scientific software and introduction to CernVM-FS. So I guess that some of the questions that were raised before will be answered as well here. You can use this one or that one. Do you need to share your?
Yes.
Okay.
Just set this.
So, going to give you a bit of more time. So in big installations, so the question that was raised before, so in very big installations, what you usually want is to have the file system very close to you, to have more responsiveness of the solution, right? So easy, by using CernVM-FS, you can take a Stratum, a copy, a Stratum 1, locally, and then you can use even multiple proxies, because this is using just a HTTP layer. So at the end of the day, it will perform as a parallel file system, and the performance is really good as well. And if things go wrong, and you lose your local copy, you can always go to the outside internet to get that. All good?
All good.
Here you go. Thank you.
All right. Valentin Völkl, I'm the developer of CVM-FS, the CernVM file system. Thanks a lot for the organizers for inviting us here to this very nice workshop. And I have it's very nice for me today with this very nice motivation by Alan and Elena. They basically already gave you all of the motivation to use CVM-FS, is because that's how you get access to Easy, and is, I think, a fantastic software stack. And we all know how much work and how much effort goes into having a software stack that works really well and is well curated. So I want actually to take a step back now for a second and ask you, deploying software, getting actually the software binaries to where you want to run them. By show of hands, how many of you are using system package managers, YAM, APT, things like this? I guess a lot. How many are using the Python package managers, Conda? Everyone, perfect. And how many of you are using containers? All right, so also very good. And how many of you have already used CVM-FS through Easy or whatever? All right, quite a few. So, but I still I'm able to give like a bit of an introduction today. Thanks a lot. All right. Whoa, you okay? All right. Thanks a lot. All right. So this tutorial today was also prepared in collaboration with Easy, and thanks a lot to all of the collaborators, Alan, Bob, and in particular Kenneth, who prepared a lot of this material as well for use in Easy. So we have this agenda that I'm going to introduce a bit, CernVM-FS. Probably starting with the question, what's actually up with the name? Are we aware that it's very difficult to pronounce? We are, unfortunately not going to change it. I'm going to change a bit back and forth, like most of the content is on the slides, but I'll then try to hop in as well into a shell and show off kind of like a bit of the internal things, hopefully giving you a better idea of how the system works. And then talking about a few extra topics, like having exactly what was mentioned today, how to get like a copy of data, how to use CVM-FS on systems that have constraints, how to monitor CVM-FS and how to troubleshoot it. Actually, this is a very important concerns for actually when you do this in practice. And then also, I think, how to create your own CVM-FS repository. And then talk a bit about performance if we have time and want to keep it from copying. Okay, so coming back to software distribution, no? So there is especially in scientific software, a bit of a problem with scientific software distribution. And the problem is, I hope that this doesn't shock you, but if you are actually going to pull a container, here I have this example of R, this statistical language, you would pull this container that's around 1 gigabyte, and then you run a part of it, like this, if you run basically like the minimal working thing in this, which is a fitting tutorial, you use about 30 megabytes. And actually, like if you do some statistics, we see that basically this holds across a variety of containers. Like you tend to use kind of like 20% of the actual data you download. Of course, you can go through great lengths to make this more efficient, to minimize your container image, to follow all of the best practices. But in general, it becomes hard. And in particular for scientific software, where you might need to have like a very complete image that does a lot of things, but for any given workload, then you only do one thing. And you're basically then you're in the situation that you have to maintain like a lot of container images, and that's also like a lot of pain. The next thing that is kind of like hard to scale for something like batch computing and supercomputing. So is if you have an app on your phone, no, this kind of like changes maybe every month is not so big, and the updates also tend to be staggered. If you actually then do kind of like the updates on your whole cluster, cloud, supercomputer, or whatever, no. If you use a kind of like some shared file system or whatever server, this essentially turns your cluster in a distributed denial of service attack wherever you distribute your software. No? And in particular, software is bad because it's very metadata heavy. So you do a lot of lookups, you do a lot of lookups of shared libraries, of paths, you have shared, search paths. So there's kind of like, in particular, if you use things like cluster file systems, this tends to put like really a lot of load on cluster file systems. So basically then the answer, and people have been thinking about this problem at CERN for now 15 years or so, something like this. And our answer to this problem is the CernVM file system, which is a dedicated file system just for software distribution. So you mount basically a file system just to access your software. And is a read-only thing. So for the client to mount it, you will only get kind of like the installation from a central source. And is global, basically. Then looks the same for everyone. And as Alan and Eleanor just mentioned before, is really kind of like a bit like a streaming service for software. Because what happens behind the scenes is really that you mount this repository. So we tend to use /CVM-FS as a global folder just for as a convention, no? And then actually software.easy.io is the file system that is being mounted. So you have this mount point inside CVM-FS of the software. And then all of the file system accesses on the software will all be to perform their actions on demand. So you download the files. You will need to download the files from somewhere as you access your software installations. But then you do this on demand and in a way that you only access the things that you actually need. And this trades off a bit the latency with being very efficient in kind of like a batch context. And so it's really, if you do then open this file, by the time you do an LS, you've downloaded no files except for the metadata. And then once you actually print the contents of the easy readme here, you do this just-in-time download. So all of this is implemented as a file system in user space, so that makes it like very easy to deploy, and this is possible to install this very flexibly. And it has a number of optimizations that make it nice for this purpose. So Alan mentioned that there's deduplication. So in the end, this is backed by an object store. We only use HTTP transport, which makes it very easy to cache. Sort of that's usually the secret to performance in these kinds of things is always about the caching, and this is basically the architecture of different servers and proxies that allows you to then actually have a performant access to the software. And then all of the data is stored compressed, and there is some verification of data integrity as well, so you know actually that what you get on the client is the same as what is in the server. Right. So an aside for file systems in user space. This is a very nice technology of the Linux kernel, that basically lets a user space application implement a file system. And the way this works is that basically if you do a directory access or something like this gets translated as a system call, no? It goes to the virtual file system, like in the kernel. And then there is this, if it's a fuse file system, the fuse kernel module actually redirects this back up. There is this device dev-fuse where then an application can listen, and basically your request for an LS gets sent basically through this device dev-fuse to an application. This in our case CVM-FS. And so you can write an application that then basically implements all of the system calls that the kernel would do on a file system. There's tons, no? There's read dir, stat, and all of these things. And we can implement this in user space and send basically the answer back. You can also see that by design, there's always going to be some overhead, no? So you have this kind of like redirection where you go to the kernel goes back to user space. That's kind of like the price you pay for the flexibility. But I think we're going to show them some performance numbers, and in particular, we can use kind of like a lot of caching also in the kernel, which makes all of this actually perform quite well. And so what does actually then CVM-FS do with these system calls? It's actually, the concept is very simple. You access a file, and if we have this file in our local cache, we open that and use it. If it's not in the local cache, we download it from this object store. These are the servers that we saw or that we were talking about already. We place it in the local cache, and then we use it from there. And so we can have basically the files are then kind of like in this thing where they appear to be always available, but in the end you have only this working set of things what you actually need on disk. All right. And just to give like a bit of a history, then now is the question why is actually called CernVM-FS. So the VM is actually a virtual machine. And around 15 years ago, there was a period where virtualization was kind of like a very big topic. You know, and the idea was basically to try to run all of the workloads, in particular also for high energy physics in virtual machines. And actually the CernVM file system was used for these CERN virtual machines, which are supposed to run the workload. And it was actually used to distribute the whole operating system, sort of the complete root file system of the virtual machine was put on CVM-FS. And then you only needed a very, very small micro image, like it's about 20 megabytes, which is actually quite amazing. So you basically have this full virtual machine that only weighs about 20 megabytes and then will, of course, access all of the things that it needs, but this also kind of like this is where this very hard to pronounce name is coming from, actually, that it distributes the root file system for virtual machines. And so in high energy physics, we have this computing grid computing model. It's kind of like an analogy with the power grid. Is that you can basically plug in your workloads in any kind of computing resource. There are lots of universities and laboratories around the world that will contribute that will like be part of this high energy physics collaboration and then contribute their computing resources. And the challenge is to federate all of this, to kind of like connect it together and to have like a uniform layer where all of this can be accessed. One particularity is that in high energy physics, usually we do high throughput computing, not high performance computing. So we actually, typically our simulation, we have to do like a lot of them and there's a lot of data to process, but each particular workload isn't actually that demanding. So they typically fit into like a fairly small node, but then you have to like really crunch through a lot of data and to have this high throughput of these machines. So this is also why kind of like a computing model like this works well. But you can also see that then this idea of a uniform access to computing resources, how CVM-FS can be very helpful, because you just have the software available. Is there on the /CVM-FS, and there are no kind of like specific ways needs to deploy the software on if you have a data center in the US or wherever, and there are different types of resources that are administered by different people. So it allows also for a very distributed kind of like way of doing things, which is nice. And so part of this architecture is kind of like to work with this kind of distribution and this federation and all of this grid. And so CVM-FS is very well adapted here. And we turn basically this problem of this access to a central location in a very nice distributed one. We have this terminology of different strata. So we talk about the stratum 0, which is the central source of truth for a software repository. Sort of this is where you would publish your software, and I'm going to talk about this in more detail in a little bit, how you would go about doing this, installing software yourself on CVM-FS. And then there are different servers here as well, the stratum 1s. And these are basically typically complete copies of the repository, but then allow you to have kind of like be independent also from this central source. Sort of this is kind of like this model that is very well adapted to something like this, because each major grid site now can have their own copy of the software as a stratum 1, and then they can also serve serve more clients in the general geographic region. All right. And just to give you like a few numbers, sort of the deployment at CERN we have around 15 of these stratum 1s. There are a couple in the US, a couple in Europe, and then smaller ones in Asia as well. The latest count is about 20 billion files in the CVM-FS tree that are publicly accessible. It amounts to around 2 petabytes of data. We also have this feature of external files, and we have an industry collaboration with a financial trading company which actually scales this up to 100 petabytes, where they access kind of like files in an S3 bucket through CVM-FS. We have a nice synergy with container images, and that I'm going to talk about also a bit later. And here we have already around more than 4,000 container images stored unpacked on CVM-FS. Because then the benefit is basically you also get this on-demand access to then container images through CVM-FS. And you can see sort of the largest one here are the big LHC experiments. We have LHCb, Atlas, Alice, and CMS. Sort of these are very big ones. Unpack.cern.ch is the container unpacking repository. You can see that this is fairly popular, as it allows people to publish their container, which is then available everywhere on this computing grid. And sft.cern.ch is something that's very similar to Easy in its idea, in principle. This is kind of like colleagues from my group at CERN who are like installing, curating a software stack, and then installing this here. And this is kind of like then used as a shared dependency for all of the experiments. And then I think we also have, what's also nice is that there is this long tail of smaller repositories which are also being used in astronomy. There's the LSST, there's LIGO, and a lot, there's the Euclid telescope, which by the European Space Agency, they're using CVM-FS as well, and sort of there's really, it's used very widely in the sciences. All right. So this is kind of like a bit of a map of CVM-FS and the different things that are here. So in green, you can basically, I see the core software, which we call the client. This is this Fuse module that lets you access the software that's downloaded from the server as if it were basically just there installed on the local disk. And then there's the server. This is the different tools that allow you to set up a repository and then actually publish content into that. We have some services, starting with the gateway is a type of thing that allows you to have many publishers connected to a single repository to parallelize this authoring thing. And then we have container publishing tools. And in particular, with the containerd snapshot. I'm going to talk a bit about this in a bit. This is going to be like I think this is a very interesting piece of technology as well. And there are a few other utilities, the preloader and shrink wrap. These will help you to deal with systems that have particular constraints and where you need to do special things. So there was this question about how to actually get data out of CVM-FS. So the shrink wrap is actually one of these tools that allows you to do this. In principle, this does kind of like an rsync of all of the data out of CVM-FS, but it keeps this deduplicated structure. You might, you can imagine that you have a software installation v1.0 now, and then a software installation v1.1, and this shares maybe it maybe shares a lot of files. Maybe some particular library wasn't touched at all in the update. And so there's actually no need to copy this, if you have this in different prefixes, there's no need to copy the data file twice. And so since we have this content addressable object store, this shrink wrap allows you basically to just copy the object store and then symlink the files to the object store and then preserve this. The preloader is then also a way to load the cache in case of that you have kind of like limited network connection. So you can populate a cache and then use it in a context where you then don't have network connection. We have a few extra tools, sort of the CVM-FS exec. This actually I'm going to demo in a bit. There's some monitoring tools. There's a nice utility that allows you to set up CVM-FS easily on GitHub Actions. This is quite popular for like CI workflows. If you have software on CVM-FS, that you basically it makes it easy to you just use this action to install this on GitHub, and you have it there. There was an authentication helper. This is a topic where there might be a few questions, is how you can kind of like restrict access to CVM-FS. It has this model that is like a global public access to all of this data, but there were efforts to also make it authenticated, and there's different monitoring things. Right. So I think I'm going to now quickly demo a bit how to install and use CVM-FS. I mean, in principle, you saw this as already for easy, but I'll basically walk through this briefly on the slides and then also show it, hopefully, if that works with the internet connection on a machine that I have here. So in principle, if you want to just use the software, it should be very smooth in a way. So it basically just install this client software. You have to do like a minimal bit of configuration, and then you basically just set to go. In particular, if you use AutoFS, is kind of like a very seamless thing, and I'm going to show like a few different things. In particular, the configuration is important. As to specify kind of like if you want to use a proxy, it's very important to use the proxy, and also that this is something that is typically there, and this cache, this disk cache configuration is also important. All right, so we do have packages available for most distributions, and on Linux there's also packages available for macOS. I don't know but then again, you also need to have a software installation for macOS if you're going to use this. So it's maybe less interesting in the context of easier or supercomputers. But for Red Hat-based operating system is really as simple as this. We're trying to get CVM-FS also as well into upstream distributions. This is still like a bit of work remains to be done there, as there are some packaging guidelines that you need to follow to do this. And then basically the configuration, we tend to kind of like dog food the usage of configuration here, in that we have repositories that actually ship CVM-FS configuration. So you can load these config repositories, and then you have the CVM-FS configuration accessed via CVM-FS. Which is a nice model in kind of like this grid style setups, where you can then easily change the configuration in a lot of places. So this is kind of like one very nice way. And for easy as well, there is a basic configuration here. It can be nice to also then have it on the local disk, and then there's also configuration packages available here for easy to do this. And here there is basically this very basic configuration that you need to do to actually use CVM-FS. So all of this goes into this local configuration. This is kind of like the default way to to configure CVM-FS. The important ones are the HTTP proxy. This can be set to directly go to the Stratum 1, to the full repo, but wherever is possible, it's always good to use a proxy. Then there's the quota limit to actually set this has some default where is kind of okay, but it tends to be good to adapt it to your system, because it also depends on the particular software, how many repositories you use. If you have things like TensorFlow, no, that tends to be something which is also quite heavy on resource usage. All right, and to do all of this, let me see if I can show this here now. Just make this a bit bigger. So I have basically a very plain and new setup Alma Linux 9 machine. This is kind of like the Red Hat based thing that people tend to use at CERN, and this is basically pretty much fresh. And what I'm going to do is just to go to our getting started page for CVM-FS. And there we have these instructions on how to actually download CVM-FS from our packages. And I'm just going to copy and paste this. This is the release packages sets up the repository that we have set up for CVM-FS, and then we just install it. All right. So this is working. You can see that we have the dependencies on Fuse, AutoFS, and various things. So now there is one step to do is to run CVM-FS config setup, which also will do the AutoFS configuration. And then we have to add this very basic configuration that I was talking about earlier. So in this case, we just do CVM-FS HTTP proxy equals direct. And now I think AutoFS should be running, and we check this. It's running, yes. And so we should, in principle, be able to just access CVM-FS now, starting with the configuration repo, that's CVM-FS config.cern.ch. And this then has kind of like mirrors the structure of the configuration on disk. And you can see that then for the domain.d, there is then, for example, different configuration files for different repositories. All right, maybe it's then interesting I think to take a look a bit in the internals of how this actually works. So I mentioned that we have kind of like a local cache, and so this is located under varlib CVM-FS, and you have this shared for different file systems, and this is our cache directory. And you can see actually here is this object store in action, because these kind of like hexadecimal prefixes, these are actually the hashes of the files. We won't have like a lot of files here, since I just basically mounted this repository. So let's see if there's anything here. We tend to have, so basically all of these folders are empty, you can see, no? So we don't really have, there's a few exceptions, sort of a few files always get used when you mount the repository. And the metadata in CVM-FS is called catalogs. This is basically all of since the files themselves, they are stored under the object hash, we need to keep track of the file paths, and this is the metadata. And now let's see if actually I do like a cut on various things in CVM-FS config.cern.ch. So now I'm going to actually do an access to all of those. So here this is basically all of the config file that I've just read. And now in the cache directory, CVM-FS shared. So right, so now we have a bunch of these files here in the cache that were actually not here before. And I bet I have to be a bit lucky that I don't hit one of the catalogs here. But in principle, what I want to kind of like demo is that this is really just the files that we have basically here in the repository. So if this is then kind of like the way this works. That you have these here in local cache, and any file with the same content will always be just stored once here in this local cache. So if this is then the basic way here. And what I want to show off as well is that we have a few tools. This is one of them is CVM-FS Talk. CERN.ch, and then. So if this lets you talk to a running CVM-FS instance, and it gives you kind of like a nice bits of information to actually then interact with CVM-FS. So if this is kind of like a nice, a bit more advanced administration tool, but it can be very interesting to know about it. For example, then we can here do cache list, and we'll actually show that all of these configuration files we now have in the cache. And we can also then ask it about the cache size, for example, and see that it's okay. All of these configuration files are not really big, but so it rounds down. But in principle, this is kind of like the way to interact with the CVM-FS repositories. Okay, I think I'll leave the demo for here. We can come back here to then look at the the creation of the repositories. I'll just go ahead and get this started again, and talk a bit more about the architecture and the deployment that you would do on CVM-FS. So because if you have a handful of clients, no one server is enough. But in principle, the recommended deployment then is really to go from the Stratum 1 server to dedicated, from the Stratum 0 server to dedicated Stratum 1 servers that mirror the entire repository. And then if you have a bigger setup, to set up proxies. And yeah, it's actually quite easy. You typically only need a forward proxy. And that is quite easy to set up. And these are basically a partial cache of CVM-FS repositories. Now, one thing that we hear a lot, especially for easy, is that it would be nice to have a partial copy of the contents of the repository. Since, you know, if you have a particular site with a particular architecture, you might not want to install kind of like, you might not want to keep the full copy of all of the architectures. Is something that we're working on, and I think that we'll also have for the next release. But in principle, the Stratum 1 copy is kind of like the full copy of the contents, where a proxy server is just basically this partial cache that keeps around the files that are being used most, and that's usually then already enough to kind of like really take a lot of load off of the Stratum 1 servers. The way the Stratum 1 servers then works, that is that they do a periodic sync with the Stratum 0 ones. So I'm not going to go into details with this today, but you basically then just set up this as a cron job, and then they will just kind of like keep up to date with the Stratum 0. For easy, it's about 360 gigabytes of disk space. And at CERN, we're about a terabyte per repository, so that's really, that's pushing it quite a bit, but this also can scale quite well. And I think a nice side effect as well of this object store is the software preservation. So once you have this object store set up, in particular in a scientific context where you want to go back to old software versions if you actually need to reproduce something and do something, this can be a very nice side effect that you have all of this object store with all of the data. All right. I think that I'm not running too late. I think I will skip the configuration of the Squid server, but this is kind of like the default way of setting up a server for CVM-FS, and it's quite straightforward. It is good to use a forward proxy because the client itself has some logic that does failovers, and so it has this different list of stratum 1s and will actually then is quite smart in actually doing failovers and selecting different things and going from A to B. What we have investigated as well is different options, as Squid is a nice piece of technology, but is aging a bit. And we've tried out Varnish, and we've also had the Varnish developers at our last workshop. And this is if anybody's interested here, we have this working configuration, and this is a good option as well to set up proxies for CVM-FS. Right, so this I wanted to skip, and I think I'll also just go through this one fairly briefly, so you can see the requirements, the storage requirements a bit. So CVM, also Easy is growing a bit, but it's not like an unbounded growth. So it's still quite possible with limited hardware to actually run a full copy of Easy on your local site, and then you're also independent of this central architecture. It is recommended though to have a relatively fast disk in order to have these synchronizations be fast and reliable. This is the way that you would add repositories to a Stratum 1 mirror server. So you basically just need the public key, a little bit of setup for kind of like which actually URL you're going to use, the keys, and then this add replica command does everything for you basically, sort of that you set up a Stratum 1, and then you do the snapshot is what we call the synchronization of the replica. So if you do this for the first time, it's going to take likely several hours. I think the last time Kenneth tried it out, it was around 6 for a new machine for Easy. Then of course, then the next one only fetches the diff of the new software that was added to Easy. Right, and then you can basically add your Stratum 1 to configure your clients to use your Stratum 1 server. Here you add this just to the CVM-FS server URL. It's not recommended to do this without a proxy, as this kind of like puts load in the machine that already does kind of like the snapshots and synchronizations. So you basically then add as well the Stratum 1 to the proxy configuration and the proxy to the client configuration, like this. Another nice tool is the CVM-FS config stat. That kind of like then also tells you a bit about the network usage and the things that are being used on CVM-FS. So before going to the coffee break, I want to briefly talk about some alternative access mechanism for CVM-FS, as in particular HPCs can be a bit challenging in terms of setup for CVM-FS. What is the problem? So you might have offline or diskless worker nodes, or that you're lacking admin rights, that actually you cannot install the CVM-FS client and the local admins don't want to install it. But there are some workarounds, let's say. These all come with some kind of trade-off, but it's possible to make it work. So the best case, obviously, for us is that we have access to the internet on the worker nodes. There is a local disk which we can use for the cache, and the internet is basically we have the full connection to the outside world. The worst case is kind of like this completely decoupled machine, which basically doesn't have really access to the outside world, and then has also like not really a local disk that you can work with. So this would be kind of like the worst case in some sense. And you can see that this is taken from a presentation from high energy physics, that the very complex workflows that people use to actually then put things in CVM-FS. I've mentioned the CVM-FS shrink wrap tool. So if this is being used in this workflow to actually get the data out of CVM-FS, and then people have actually also like really created frameworks that trace the software access to CVM-FS, so that you actually then shrink wrap only the things that you really need for a certain job, and then you kind of like ship this to this node where you can't really run CVM-FS. So shrink wrap is this tool for when you have no network connection to or no CVM-FS clients on the nodes, and you basically copy the contents. We've mentioned that CVM-FS is just a POSIX file system, so in principle you can just do a copy or rsync, but CVM-FS shrink wrap keeps this deduplication and therefore is a bit more efficient. The problem with all of this is that it's fairly labor intensive, so it's quite complicated to do. When you have no local disks to work with, there are different possibilities to do this. So the one is to use a loopback file system for the cache. So you basically reduce the cache usage to one file per repository, because this is for some cluster file system, that is the main problem, is that if you start adding many small files from header files and whatever is used in your software, that you really destroy the metadata servers of the cluster file systems. It's a valid way to use the RAM cache, and we have a feature that is called a tiered cache, which kind of like lets you use different types of caches, like a RAM cache and a local disk cache, and kind of like optimize a bit the usage of this. And sort of this is a good option to try this if this is an issue. There is a workaround of doing NFS exports to just run the CVM-FS client on one server and exporting this over NFS. This is known to work. It's also been known to cause quite a few issues. So I would caution you to actually do this. And then finally, there's CVM-FS exec, which is a tool for when you have no admin privileges, and it's quite a creative way of using CVM-FS where you don't actually need to install anything and on the system. The challenge is that, of course, the application expects to see /CVM-FS, so that there has to be some kind of way, and this is using namespaces and different things to actually do that. And I'm going to quickly show off CVM-FS exec here. So the way that you do this is also very, very simple. So you basically just clone CVM-FS exec. Get the same issue here that first we need Git. So now we're able to clone CVM-FS exec. And then it's basically just two steps. The first is this make-dist script. Make-dist basically just downloads all the CVM-FS binaries in a way bypassing the yum package manager. So what we can inspect this in a second. Make this default. This is kind of like the default configuration. There are different variation for the open science grid and different other things. You can see that basically it took all of the CVM-FS binaries and extracted them from the packages. And then we can, since we now have the binaries here, and we can now use CVM-FS exec for software.easy.io. And I hope I get this right, and just run bash. So this is kind of like then a wrapper for a command. There's
an extra space between the dash and dash.
Between the dash. No, but this should be fine. Right. Right, check. I have the thing here. Okay, an extra. Right. Yeah, the demonstration effect is here. All right. I think so there are different ways here of also using this sort of there's mount repo, seeing CVM-FS, all of these kind of like use slightly different things to then do CVM-FS. Okay. I'll leave it there since we run out of time, and then try to debug this later. Now I quickly want to talk about monitoring because this is something which I think is very helpful for any kind of deployment, and we also try to help a bit with different configurations to make this work. And in particular, I think the one recommendation that we have here is to look at the cache cleanups. Sort of there is, for the CVM-FS talk command that I already mentioned, there is this way of talking to us running CVM-FS process, and then we have this number of cleanups in the last 24 hours. And if this is too frequent, sort of like that's too frequent, meaning that is happening more often than the length of a typical job, your cache is probably too small. Sort of this is the best way also to kind of like double check the configuration. And we have the CVM-FS contrib area here as well. I'm happy to share the slides with these links. And where basically there are different things that the community contributes, where you then actually also can take a different look. And just as a quick demo here, I can show you this. Actually, I've opened it here as well. So this is one of the dashboards that we have at CERN. This is a fairly small one. This is just for basically a shared compute cluster that is Alex Plus. It's a very old school kind of like multi-user login system, so people can log into these machines. There's about I think a few hundred of them, and then run different types of workloads, and it's quite popular for people to just try out and run some smaller things. And there are different things here like monitored, and this is using this collectd plugin. So that this is also then something that should be easy to set up. An interesting thing is this max diff from latest revision. So that the revision is kind of like the version number of your repository. And we've seen that the Stratum 1s need to do these snapshots to keep up to date. Sort of inherently in the system, there can sometimes be a small delay between when you publish the newest software and when it actually shows up on the client. And this is kind of like a good way of monitoring this. And we have this is typically repositories that publish a lot, where you can see like a little bit of a difference. For the rest of them is completely fine. So here that's lhcbdev.cern.ch, which is a repository for the LHCb experiment, where they basically publish the binaries for all pull requests to do testing. So that this is you can see that this is going to be then used like quite a lot. And the other one is unpack.cern.ch, which is the container repository. So here that there's also like a lot of containers being added all the time. And then here. The mount time, I'm actually not sure why they monitored it, but it can also give you some indications of if the machine is overloaded, and what is this is kind of good. And then there's this basic checks just to check that everything green. Here is this, and here is what I've mentioned already is the number of cleanups. So there was kind of like one which did 2 cleanups in the last 24 hours, which is actually also still not that bad. All right. And then I think as a final, I want to mention still 2 topics very, very briefly. Sort of one is the troubleshooting. Like, there's a lot of benefits to having this as a file system, but one problem is that actually we're a bit limited in kind of like the errors we can report. So you do an LS, and we can only basically tell LS to report an error. So the typical things that one should check for is basically the configuration. Sort of, and there's also a CVM-FS config check setup command that allows you to do this. Connectivity issues. We've just I think very recently had someone who tried out Easy at a university in Germany, and they had their proxies configured in a way that that they would block certain requests, which was then kind of like a bit hard to debug. But this is typically when you just get an input-output error on accessing CVM-FS, because we don't really have a way of giving you a detailed error message for the application when it is. There are detailed debug logs, but you typically have to look into the syslog. Insufficient resources oftentimes is really about the cache directory, because you still cannot open more software than you actually have space on local disk for. That's kind of hard. And then all of the log messages are typically in the syslog. And here's kind of like a bit of 2 slides where I do like a bit of a translation of some errors that you sometimes see, which come basically from Unix and which are a bit hard to interpret. So one thing that sometimes we see in the bug report is this message of too many levels of symbolic links. This isn't actually that there are too many levels of symbolic links, but this is usually an attempt to access a mount point within a namespace without actually sharing this namespace. So this is this feature that if you have a container, you bind mount something, but you actually have to share it to propagate kind of like the mounts inside /CVM-FS. This is the solution here is basically then just basically to share this if you use this in a container. No such file or directory. This can we basically have our metadata that are directly there in the cache, and if you have caching problems and the catalogs cannot be loaded, then this can also happen that basically you don't see the paths that are there. And this is typically where you want to look in the syslog to do this. And then there's 2 error messages related to fuse. One is software caused connection abort. And this is that the fuse connection has been cut by the kernel. This usually only happens when admin intervention, and then you need to kind of like remount the CVM-FS. And one is transport endpoint is not connected. This means that the user side of this fuse thing, the CVM-FS2 process on the user side has died. And then again, you need to unmount and remount. And usually when this and this is kind of like a rare scenario if that does happen due to out of memory or whatever. Actually, we try to unmount and mount automatically, but in some rare cases that actually doesn't work then. Right. I think actually I'm going to skip now the creation of the CVM-FS repository. In principle, that's fairly easy with this mkfs command, and then basically there are these 2 commands: transaction and publish. And while you have a transaction open, CVM-FS becomes read-write, and you can actually then just install stuff using spec, easy build, and whatever, and then you publish things. There are additional topics here. I think one thing I want to mention still is kind of like the startup performance. So this Kenneth has done some very nice benchmarks, basically looking at different types of startups when you actually try to load softwares. We typically take TensorFlow as is kind of like a nice stress test. It has a couple of 3,000 files, a gigabyte of data. And so there's a couple of plots, and we start basically with kind of like a few observations. The first is that it's that the ideal thing is that you actually have this in RAM disk, and this is kind of like the difference of having the software on local disk. It takes a couple of seconds maybe to load the TensorFlow, and if you have this on RAM disk is 2, sort of is a noticeable difference. But this difference kind of like appear when you make use of the kernel caches. So is kind of like also the local file system access then becomes kind of like very fast once you actually use then kernel caches. So the next is the NFS is a bit worse, especially on the cold cache, if you use network file systems. And then GPFS and Lasta are actually fairly bad. So here then there's different configurations here. So the SSD and typically like you can see that here you go into kind of like 30 to 60 seconds for importing TensorFlow and the Python package. And now to CVM-FS. And here, actually on this plot, you see a bit the difference between having the data very close, kind of like with a private proxy, then you get kind of like really to the order of seconds. If you don't have the proxy, you talk to the Stratum 1, it's still kind of good. If you then talk to the kind of like the general servers, then you have a lot more network access time, and the performance actually becomes better. So this is good to keep in mind that to actually tune performance in these things. And then actually also then the usage of the caches, and we distinguish between a hot cache and a warm cache, which is basically the kernel file system cache. When this is filled, then is actually also very close to when you actually have it just in the local disk. If you have done this on RAM disk, and then it's all still kind of acceptable, I think, if you have even when the Stratum 1 mirror servers are further away. All right, and there's a very final mention. I think this is one very nice technology. Is that for CVM-FS we have this possibility to unpack container images, and we actually have a containerd snapshotter that allows you then to use containerd directly to talk to CVM-FS to get the image layers. And I have a very brief demo. We are actually at KubeCon to present this containerd snapshotter. I did a brief demo. I think that it's the best impression to just do this. Yeah, here we go. So I'm going to pause this very quickly just to explain what's going on here. Let's make this a bit nicer for the quality. I'm hoping that we actually get, if I manage to show this. So for Easy, actually, it's not an issue because they have a very creative and nice solution to do the same isolation without containers actually. So what we have here before I'll go into this. So on the top left here I have a terminal where I load some containers. On the bottom left there is a kind of like a simple network monitor that just measures the amount downloaded, and then we have some iNotify type folder watchers that just show the activity in kind of like the containerd cache directory where containerd usually loads layers, and then in the CVM-FS cache, the one that I basically showed you before. And whoops, right? Sorry. But okay, so we go. Here. It should be very brief. So I use nerdctl to pull a Python image, and that using nerdctl, I think nowadays you can also configure Docker to do this. And you see, you have a couple of layers that you need to download. The network usage, basically, it's about 300 megabytes, and you download the whole thing. You have to wait a bit, around I think is maybe 20-30 seconds, and then you populate kind of like all of the containerd things with these different types of layers. So it should be done here. It takes around 30 seconds or something like this, and then you've loaded the complete Python image, and you can use it. I'm just going to actually remove this now. So I do an RMI, and you can see that most of this stuff is now gone. And then just you see the image is gone as well. And then I do the same thing and pull the thing using the CVM-FS snapshotter. So that this is then this way in containerd to specify which how actually containerd gets access to the layers. And here we basically then pull the layers from CVM-FS. And here you can see that the startup is basically immediate. We didn't need to wait 30 seconds, but basically we have the image then here directly. So the thing is, it does the same lazy loading as CVM-FS in general. So it has done the different files already, kind of like it does this all on demand. And you can see that also the needle didn't really move on the network that we're actually using, but now it's going to do this. Of course, at one point we have to download, and you can see here, I do something non-trivial in this Python image, like import setup tools, and you can see that now actually all of the files are actually being accessed and being used. But the point is also that, that there is some latency then, of course, if you do this in interactive use, but we still kind of like were very efficient. So we didn't download 300 megabytes, but it was just basically 4. And sort of this is the demo for our containerd snapshotter, which I think is also quite nice. All right, and with this, thanks a lot again. In particular, I want to acknowledge like all of the contributions from Easy for doing this tutorial, and thanks again for the organizers for the invitation. I have also a list of Outlook on new developments. I'm just going to flash them, and if anybody wants to talk to me about this, then I'm happy to do so. So thanks a lot.
Thank you so much. I think we have time for very short questions, a couple of them. Otherwise, we can attack you during the coffee break.
Well, I had many questions. Jordi can, but I'm gonna select the most important ones, and then, if I may, I will catch you in the coffee break. Can I change the barlib CVM-FS directory to another one? If no, can I use a symbolic link to change it?
It's configurable, yes. I'd have to look it up, but we have this here in I think the docs CVM-FS. That should be fairly easy to find, actually. So
don't worry.
The parameters, and we have, okay, I think that here is kind of like the page where you have all of the configuration parameters, and yeah, here you have it, cached here. This you basically set in the configuration. You have, this is the parameter here.
Another book? Are you following ALMA path? I mean, while an ALMA Linux is still on live, you provide support for that distribution of ALMA for
yes,
CVMS repository?
Yeah, so for Red Hat-based Linuxes, for sure, I think these are still used a lot. We try to support kind of like Debian as well as a second leg for this. But since Alma Linux 9 is used by all of the LHC experiments, that for sure and we're open to. I think we also have packages for Fedora and SUSE as well.
8 is still working.
8 is still working, yeah. 7 is on its way out.
Okay, so thank you again.